Imagine an object moving so fast, it could fly from New York to Tokyo in under 60 seconds. Now imagine flying that object directly into an atmosphere of 1,000,000 degrees. No human has ever been here. No machine was ever supposed to survive this. But right now, as we speak in January 2026, one spacecraft is doing exactly that. Today we check in on the fastest, hottest, and most daring mission in history, NASA's Parker Solar Probe. Just weeks ago, in December 2025, it completed its 26th dive into the sun's corona. It is alive, it is healthy, and the data it is sending back right now changes everything we thought we knew about stars. Buckle up, we are going to touch the sun. First, we must answer the obvious question. How does it not melt? The probe is flying through the solar corona, where temperatures can soar above 1,000,000 degrees Celsius. Yet the instruments inside are sitting at a temperature similar to a summer day on Earth, about 30 degrees Celsius. The secret weapon is the thermal protection system, or the shield. It is 2.4 meters wide, but only 11.5 centimeters thick. It's a high-tech sandwich. 2 sheets of carbon-carbon composite surrounded a core of carbon foam, which is 97% air. On the front, a white ceramic coating reflects as much light as possible. This shield is so effective that while the front face is being roasted at nearly 1,400 degrees Celsius, the back remains cool enough to touch. But here's the engineering paradox. To run the spacecraft, you need electricity from solar panels. But if you expose solar panels to the sun at this distance, they will superheat and degrade in seconds. The solution? Articulated wings. As the probe dives close, the computer automatically folds the panels back, tucking them safely behind the heat shield of the spacecraft. Only a tiny sliver is left exposed to generate power. To keep them from melting, a high-pressure water cooling system flows through veins in the panels, dumping excess heat into space. But a shield is useless if you don't point it the right way. Out there, light takes 8 minutes to reach Earth. If something goes wrong, mission control can't help. By the time they hear about it, the probe would be destroyed. So Parker is autonomous. It uses tiny sensors on its edge to detect sunlight. If the spacecraft drifts even 1 degree and the sensors feel direct sun on the delicate body, the thrusters fire instantly to correct the angle. It is the smartest, toughest robot we have ever built. But surviving the heat is only half the battle. To touch the sun, you have to catch it first, and that is harder than you think. You might think falling into the sun is easy. It isn't. Earth moves sideways at 108,000 kilometers per hour. If you launch the rocket straight at the sun, it would miss and just enter a wide orbit. To get close, you have to slow down and cancel out that sideways motion. For 7 years, Parker's Solar Probe has been playing a cosmic game of billiards. Since its launch in 2018, it used Venus as a brake. 7 times it flew past Venus, stealing a bit of the planet's momentum to tighten its own orbit. The final gravity assist happened in November 2024. This kicked off what NASA calls the grand finale. On Christmas Eve, December 24th, 2024, Parker made history. It swooped just 6.1 million kilometers from the sun's surface. That sounds far, but if the sun were a basketball, the probe would be just 10 centimeters away. At that moment, it hit a top speed of 690,000 kilometers per hour. That is 0.06% the speed of light. Why so fast? Simple physics. Just like an ice skater pulling their arms in to spin faster, Parker accelerates as it pulls its orbit tight against the sun. It didn't stop there. Throughout 2025, it repeated this death-defying dive 3 more times. Most recently, on December 13th, 2025, it completed its 26th perihelion pass. It is currently in the most dangerous phase of its mission. There's another layer of tension during these dives. When Parker is at its closest, the sun acts as a massive source of radio interference. Sometimes the probe is on the opposite side of the sun, completely cut off from Earth. For days, the team at the Johns Hopkins Applied Physics Laboratory waits in silence. They don't know if the probe survived the pass until it swings back out to a safe distance and phones home. every green beacon signal received in 2025 was a massive relief. So it survived the dive, but what did it find? Remember how we used to think the solar wind was just a steady breeze? Parker found out it's actually more like a whip. One of the biggest mysteries Parker was sent to solve is the solar wind. This stream of charged particles flows from the sun, washing over the planet. From Earth, the solar wind looks uniform, but when Parker got up close, it saw something violent: switchbacks. Imagine a magnetic field line flowing out from the sun. Suddenly, it snaps back on itself like a cracking whip before straightening out again. These switchbacks happen rapidly, sometimes lasting only seconds. They're essentially magnetic explosions launching jets of plasma into space. Scientists now believe these switchbacks pack enough energy to potentially explain the coronal heating problem, the mystery of why the sun's atmosphere is millions of degrees hotter than its surface. Parker is also taking pictures. On board is an instrument called WSPR, the Wide Field Imager. WSPR looks sideways into the solar corona to avoid burning out its sensors. In these images, Parker confirmed a theory that was nearly a century old: the dust-free zone. Our solar system is filled with cosmic dust, debris from asteroids and comets. But theory suggested that close to the sun, the heat should be so intense that this dust would simply vaporize. As Parker dove closer in late 2024 and 2025, WSPR saw the dust thinning out. It effectively flew into a zone where matter itself is being boiled away by the sheer proximity of the star. Analyzing data from the late 2024 passes, scientists also saw something unexpected during a coronal mass ejection, or CME. Usually, we think of these explosions as blasting material away from the sun, but Parker's camera saw a U-turn. Some supercharged magnetic material didn't escape. It fell back into the sun. This magnetic recycling changes the structure of the sun's atmosphere, setting the stage for the next explosion. But there's one mystery that has bugged scientists for decades, a boundary that marks the difference between the sun's atmosphere and deep space. Parker didn't just see this boundary, it crossed it. It's called the Alfvén Surface. Think of it as the point of no return. Below this line, the sun's magnetic field and gravity are strong enough to hold on to the solar wind. Above this line, the wind breaks free and rushes out into the solar system. For decades, we thought this line was a smooth bubble. Parker revealed it's not a solid wall. It's a shifting, wrinkled layer like the surface of a stormy ocean. During its recent dives in 2024 and 2025, Parker spent significant time below the surface. It was effectively flying inside the sun's atmosphere. While inside, it flew through massive structures called coronal streamers, giant canyons of solar gas that we usually only see during a total solar eclipse. Timing is everything. When Parker launched in 2018, the sun was quiet, but now in 2026, we're near the peak of solar maximum. The sun is raging with storms. This was the ultimate lucky break. Parker is now sampling the Alfvén surface while it's expanding and chaotic. It's like flying a plane into a hurricane to understand how the wind works. Why does this matter? Because this is where space weather is born. Solar storms can disrupt GPS, damage satellites, and even knock out power grids on Earth. The data downloading right now from the December 13th pass will likely show us how these solar storms are born in real time. By understanding the magnetic physics at the surface, we can better predict when a dangerous storm is heading for Earth. We're entering the final chapter of this mission. The probe is moving faster than a bullet, hotter than lava, and it's running out of time. As we look ahead into 2026, the Parker Solar Probe continues its lonely, dangerous orbit. It has already achieved its primary goals. It has touched the sun. It has broken every speed record in the book. Eventually, the thrusters that keep the shield pointed at the sun will run dry. Without fuel, it can't turn its shield towards the sun. In a fraction of a second, the intense heat will destroy it, and Parker will become part of the very star it studied. But today, that day is not today. Today, the mission continues. The data stored on its recorders is being beamed back to Earth via the Deep Space Network as we speak. Decades from now, scientists will still be analyzing the grand finale orbits of 2025 and 2026. This little robot didn't just make history, it touched the face of a god and lived to tell the tale.